good afternoon and welcome back to CS240. This is Intro to Computer Systems. And we have been going on our transition to Act 2. So I want to first chat about sort of what have we done already in MP6? Because I think it'd be good to kind of chat about like, what did we build in MP6 and how is it helping us build apps? How is it helping us build what we want to create? So first, MP6, how was it? Okay, whose team, like, it was among the easier half of the MPs we've done so far? Okay. And how many felt it was a harder half? You guys not feel the other way? In the middle, so exactly in half? Yeah, pretty short but leads you to think more. I think that's actually going to be the theme of a lot of our Python programming. Because really, this was what? I'm guessing if you did it efficiently, like how many of you guys felt like you wrote under 25 lines of code? Yeah. So certainly there's ways to do it with a lot more code. I actually think my solution was like 10 to 15 lines. And I did a little bit of additional error checking to just make sure that I printed a few things out. So, and that's really going to be a theme of the second act of this course, is every line of code is going to do an incredible amount of work. So when you build the Flask server, you have that def line. They say def like index, and you give it a function, and you annotate, or you decorate the function with the which method it calls. So you say like at method is 0. So in fact, if we pull up, I'm going to just pull up code for this lecture, but, or even, here, we'll do a simpler one. So you have this app route command. So like you have built this route, and if you look at like lines 6 and 7 up here, this def route, or said app route, this get index, that single line of code, or 2 lines of code, what is it doing? So what is Flask doing behind the scenes in just that 2 lines of code? Yeah, Jake. Yeah, so the function itself is going to send back a response to an HTTP GET request, right? So how many lines of code did you have to write in MP5? I'm guessing hundreds, right? Did anyone, like MP5, I'm guessing like 100 to 200 lines of code for the server part of MP5? Is that a reasonable? Yeah. So basically 200 lines of C code to actually get an HTTP packet, parse what that header is, the fact that it said get slash HTTP 1.1, it had a whole bunch of headers, had payload, all that stuff you did on MP5, we've now compressed down to 2 lines of code, right? So all of that work you did to understand how an HTTP packet works, it's happening behind the scenes now. Now, we essentially just say, what is the route that we care about? So here I just care about that slash route, which in MP5 we said if there's nothing there, we just served index.html, right? So we looked at that slash route. And now in response to that route, we get to do something else. And when we return something, it figures out how to make it a correct response packet, right? You don't have to care about what the content length is. You don't have to care about the encoding. All of the stuff you did on MP5 is done for you now. So all of it still used HTTP. Everything that you did in MP5 is still happening in MP6. It's just now happening with the Flask library, or the Flask library is doing it for us. So this is huge. This is big. And this is really the theme of what Python gives us. Python's going to be a great language to use interfaces and tools that build on the foundations of systems. So this doesn't get rid of everything you did in MP5. If you were to debug this program and you were to see every single network packet that went over the server, all those network packets are exactly what you saw in MP5. your MP5 could talk to a Flask service. But we're abstracting away that complexity so we can think about building higher level applications. So does that make sense on what's happening and connecting MP5 and MP6? Because nothing you did in MP5 went away. All we're doing is abstracting it away. And in general, the solutions you're going to see on the MPs that we're going to work on in Act 2 are going to be fewer lines of code, but way, way more complex lines of code. Like many of you guys, if you read through the documentation, you got the file in some file object, and then you probably did file.save. Is that a function that all of you, did you write the file? Who wrote file.save somewhere in your code? Use the save function as part of the file response object? Yeah. So almost all of you saw that documentation where you did file.save. That alone abstracted away what? 20 lines of code to save a file in C? So in C, you had to seek to the end of the file, figure out how large your buffer is, read the entire file into your memory, then write out that entire file to another file name, right? So in Python, that file.save now abstracted away another 10 or 15 lines of C code. Somewhere inside Python, it's doing all of this work. It has to figure out how much memory it needs to save the file. It has to create that buffer. It has to write the file data into the buffer. Then has to create the file, create the directories that the files are needed, save the actual file. Nothing that we talked about in the previous MPs aren't actually happening here. So it's still happening. You're just seeing it happen in fewer lines of code. So that's going to be the theme of a lot of what you see in the Python MPs. Is we're really going to focus on concepts that would take hundreds and hundreds and hundreds of lines to build in C. But because we can do them in just a couple lines in Python, we're able to build bigger and more complicated applications. Yeah, Lloyd. Oh, how does it know that it goes to index.html? That's just a convention you use on web services, or web servers, sorry. That's not always going to be true. So generally, we're actually not going to build web servers for the most part. So like this, so let's talk about this application, which we'll talk about again in a second. But what is the human level description of what this web service does? Yeah. Yeah, so if you go to that route using a web request, you're going to get either heads or tails. So would you say that this is a web service that flips a coin for you? Is that a good English level description of kind of what this does? We have a web service that flips a coin, and is it a fair coin? Yeah. So right now it's a fair coin. So if I run this, I can do cd15, cd coin service, and then Python -m flask run. And it's going to give me a web address. I can go over to my web browser, and I can see that I flip a coin and I get a heads, and I refresh it, I get heads, heads, tail, up, I got a tails, tails. So this is a web service that flips a virtual coin. Every time we make a request to the server, it flips a coin and returns a result. So if we go to any other route, so if I say /WAF, the web service does nothing, right? So how do I, if I want to make /WAF actually flip the coin, what do I have to do? Say what? Change the, yeah, change the route to /WAF. If I do that and restart the server, now if I go to the base route, it does nothing. But now if I go to /WAF, it flips the coin. So it controls exactly, the route controls exactly what happens on that route. So we can define special things where if we go to slash, we might want to view index.html if nothing else is there. But that's logic that's going to be specific to our server. We get to decide exactly what happens on every single route on the website. So I'm going to fix this to go back to just slash. So we get to control everything about our service, and we can build anything we want. So, yeah, Aaron. Slash at the end necessary. That's actually a really great question, and I don't know how Python handles it. So if I just did, because there's kind of 4 different combinations. If I just did slash WAF here, my guess is that if I put the slash on the server, it does not find it. So if there's no slash here, but slash on the server, that's really looking for a directory. I've got to do it not as a directory. If I put the slash here, then how does Chrome handle it? Let's see, slash is there. If I don't have a slash, oh, Chrome actually automatically puts a slash at the end, basically saying, okay, maybe you meant the slash at the end. Actually, something really interesting happened. So my only route is slash WAF, slash, right? Trailing slash. So I requested WAF without a trailing slash, right? It made a request to WAF on the server. And look what happened here in my log files. When I went slash WAF, it didn't return 200, right? It didn't return the OK status code. Instead, what status code is that? 308. Permanent redirect. So there's inside the Flask application, they say, oh, if you don't have the trailing slash, I'm going to redirect you to the one with the trailing slash. And I'm guessing that's an option you can turn to configure it off. But they are different routes, like slash WAF slash and slash WAF no slash. Like that's 2 different HTTP headers, right? Like if you built that in MP5, those are 2 different if statements. Those are 2 different comparisons. So they're not the same exact route, but clearly Python's going to redirect you inside, and we can see what's happening in those log files. And I feel like unless you understand the HTTP verbs, the fact that 308 is actually a status code, and that status code means something, and Aaron was able to Google search it, I'm guessing, and actually look it up and see what 308 meant. So this is kind of how you have a deeper understanding of how everything works together, how you're building applications and understanding the foundations of how you're building things. Cool. Any questions? Yeah, Skander. Oh, how do you format CSS? How do you build? So that's going to be talking more about front end. We'll talk about front end in like a week. So basically, we can return HTML and CSS and make things look pretty. But front end, there's a whole bunch of frameworks, there's a whole bunch of stuff to make front ends any way you want. So there's things like React, there's things like Angular, there's things like Vue, there's things like, jQuery is kind of front end. There's things like Express as middleware that can do front end templating. So there's a whole wide thing of front end. There's this great course called The Art and Design of Web Programming that Rajita Kumar teaches. It used to be $498. Does anyone know the number? It just recently got a real number. It used to be $498 web, but that class is all front end. So we're going to talk like one day on front end on how to connect the front end to all this back end stuff. But we're going to mostly focus on how do we actually get data inside, how do we get data from a server? Then the front end is just how do we make the data look pretty? We're going to focus on how do we get the data. Because honestly, like if we wanted to make a web app that flips a coin, like what we really need is we need this. Like how to actually make a shiny penny that has Lincoln's face on the front and Lincoln Monument on the back, and how to actually make that pretty. That's just a matter of like some art and some programming. The actual thing that actually happens, the logic is kind of what systems is all about. Cool. Any other questions? So, if not, I want to give a brief introduction on thinking about more of a design perspective now. That often what we're going to start doing is there's no one right answer. That in C, we talk about technical ways to actually build certain things and how you have the ability to sort of implement a specification where often in the Act 1, often dealing with specifications that other people built. In Act 2, I want you to begin to think about yourself as an application developer and a technical architect. And in doing so, we're again thinking about where on this stack do we exist, and we're going to think about how, as we have different tools, as we have different infrastructure containers and platforms, how do we want to integrate them? How do we want things to work together? And the most important thing to think about is the different ways we can architect services that we're building. So there are three primary styles of serverless architectures that are used frequently all throughout industry and research. So this is how do we design a web service that we're building? And the simplest approach as an individual programmer is to do something called a monolithic architecture. And the monolithic architecture, this idea is you build one program. Actually, hold on, sorry, I forgot to start the recording. So I have the recording of the main lecture, but I want to record these slides too. So I'm going to get... Okay, cool. All right, so the first idea is a monolithic architecture. So the monolithic architecture idea here is that we want to make sure that we are going to build a service entirely as one application. So the idea here is that we're just going to keep building our app, add more functions, add more functionality, add more stuff to our app, and we're just going to build it as one big giant application. So this is kind of the default way. This is the default style when building solo and without design. So if you think about you're just building a service, you're building an application, you're just going to add more functions. You're just going to add more methods that you can call. You're just going to add to the single program that you're building. And in fact, I would say almost everything you've probably built up till now has been a monolithic style architecture. You've built one program to handle your entire task. You might have broken it up into functions, but there's still just one program, one executable. You only launch one thing at a time. The alternative to this is a paradigm that got really, really popular over the past 10 years. And this is the idea of having a microservice architecture. So a microservice architecture is that each piece of your service is a separate application. And they are linked together with a web or an HTTP-based API. So in a microservice architecture, each piece of your service is an individual app. So you divide up your service into lots of individual apps. You communicate with them through sockets via an HTTP API. And you define that HTTP API so that you can interface between the different components of the actual app itself. So, and this is I would say this is the current trendy model for development. So Netflix uses this, Amazon uses this, Google uses this. Like all of the big tech companies right now use this microservice architecture. 10 years ago, they all were using more of a monolithic architecture. So we're seeing that this microservice architecture actually proves valuable in large companies. And often, if you look at startups often will start out with kind of a monolithic architecture, because they have a few developers that know the code base really well. They might have a few different services split out. They might kind of have a hybrid approach. But in general, they have these large services that do one particular thing really well. And then as the team grows, you generally see the evolution of software in the past decade or so has been that as you add more users to a team, the monolithic services are actually harder to test and harder to develop as your team grows, so you end up tending towards a microservice architecture. But this is also starting to change. Because we're starting now to see what's called a serverless architecture. And the idea here is that each piece of your service runs on demand only when needed. So this is a completely different approach than everything we've been doing so far with Flask services. So up until now, we've been doing stuff that maps very easily to the monolithic and microservice architecture. The serverless architecture says we don't have a web server waiting around to take your request. Instead, you have a function that you built, that this function is going to get called on some hardware somewhere the moment it's needed. And we're not going to worry about it just staying alive for the entire time. So this is kind of known as like AWS Lambdas is the AWS product that does this serverless architecture, where the idea is you have a single function, this function runs, the function doesn't sit around waiting for someone to call this function through an HTTP API, it waits around for some architecture to invoke this function on whatever server is available to run it. So we're going to look a little about serverless architecture, but this is the kind of new design that we're only starting to see people really adopt this at a big scale. So in theory, it's going to be great for things that don't need to be constantly running. So I think the best thing to do is really now think about these architectures. You've got this monolithic architecture, which is one application that everything's done through function calls. And you just simply write the function calls. This is like how you've coded for the past however many years you've coded. You've got this microservice architecture where you split things up, you define the HTTP API and how they communicate with each other. And then you have the serverless architecture where you have code that you know needs to run on some computer somewhere, and you don't care about persistent state. And you're going to store all of your data in the cloud in a serverless architecture so that when your function runs, it gets all the data it needs to run. And when it finished running, it saved all the data it needs to save, and it doesn't have to persist for any amount of time. So there's no state that's allowed in a serverless architecture. So what I really want to think about is how do these things compare? What are the advantages and disadvantages of all of them? Yeah?
On serverless architecture,
Yeah.
they said that it only runs on.
Yeah. So you're right that the API only runs when you're putting in a request, but as soon as you launch the Flask service, what is the Flask server doing on MP6? Yeah, it's just sitting there, right? It has to basically be there until you make that request. So it doesn't actually do anything useful until you make the request. But there has to be a server that's powered on using electricity waiting for you to make that request.
And that's like the application state that you were talking
Yeah, and the server can remember something, right? You could have global variables on that server. And so in MP7, you're going to probably have a global variable that's like your data store. And that global variable is going to be remembered from request 1 to request 2, request 3. So the difference with a serverless model is you aren't allowed to have global variables because your function is just going to run on some server somewhere, and the second time it runs, it's probably going to run on a whole different server somewhere completely different.
You couldn't store like externals on the database.
Right, but now you have to think about everything being exactly stateless. So when you do a serverless design, you have to think about what state do you need to complete the task that this function is doing, load in that entire state, work on the work you need to do, and then send that entire state back out to the database of the user. So, and you're going to find that getting rid of global variables is actually hard. Like, as you start building things, you end up having these globals that are just really convenient. Like, even like having just like a pointer to a database, that's a global. Like, serverless architecture is actually a really interesting design challenge because you can't have any form of state except for what you pass in. Do you have a question, Aaron, or did you? So does something need to run somewhere to receive the serverless request, right? So yes, like there clearly is a server that handles the serverless request. And that's what Aws Lambda does. But the nice thing about serverless request is Amazon has probably thousands of computers that are just waiting to run a task. And they're going to have to scale up those number of services when there's a peak time. Like I'm guessing like during business hours, there's going to be more Lambdas than in the middle of the night. But you don't actually get any control of what hardware you run on. So it's cheaper so if you only have a task that runs for 2 seconds, it's going to be cheaper for Amazon to just run your task for 2 seconds than keeping a server alive that runs your entire microservice all the time. So yes, is there some infrastructure to run serverless server farms? Absolutely. But as an end user, all we know is we make a call that says we want to run this serverless request, and that runs somewhere. We don't care where it runs. We don't know where it runs. And Jake, do you have a question? Or? No. Yeah. So is a RESTful API that's stateless a microservice or serverless? The answer is it could be either. So if you make a RESTful API that's a Flask web service that's just sitting there and waiting for a request to come in, that's going to be, I mean, honestly, if it's just a simple server that returns like nothing, that could be classified as a monolithic or microservice. Like it's so simple, it's hard to kind of classify between the two of them. If you have it call out to Lambdas, and then it starts up a server only to respond to that request, then it's serverless. So the fact that it's HTTP API or RESTful API doesn't actually mean what architecture it's built on. That's our decision as programmers, which one we want to build it as. And you can build it any of these with different ways. Yeah, so the architecture, what it actually does, the functionality of the program and the architecture of the program are kind of two different technical questions. Yeah, Jake. Yeah. So there's a bunch of great talks that Netflix has put out there that's on like YouTube and stuff. And I can share a link to you and everyone else in an email after class. Because Netflix is one of the first to do the microservice approach big. So they have like, I think they've got tens of thousands of microservices. Like they have really gone crazy on the microservice approach. And their big technical claim to fame is they were the first ones to do it really big. So Netflix is a classic example because they were They did it, and they were very public about doing it. They're like, this is what we're doing, this is what we're trying, this is how it works. So Netflix is the easy one. Like, there's tons of case studies on how Netflix does it. So as we think about different services, I want to think about first, as we compare these three different services, I'm going to first think about how is it developing? And I'm going to say a new developer. So the first column I want to think about, you're a new developer at a company. So you just got hired at the coolest new startup called Orange and Blue. So at Orange and Blue, you just came in, you're a new team member. Do you have any idea what their code base is? No. When you get a job, you have no idea what code's going to already exist at this company. It's probably going to be poorly documented. It's probably going to be something that's going to take you a little bit of time to understand what's going on. So you just got a good job at Orange and Blue. When you see a code base, is it going to take you more time to understand a 10,000 line code program or a 500 line of code program? 500, right? You can read through that 500 line program in like an hour, right? You can have an idea of what it's doing. If everything's self-contained, the entire app is just 500 lines of code, I'm going to guess in under an hour, you can have an understanding of what that app does. Agreed? Does that seem reasonable? And this is probably the single biggest advantage of a monolithic versus microservice approach. A monolithic is going to have a large, complex, single code base. Very hard to get up to speed. So if you go into a project and it has a very large, complex code base, it's going to take a lot of time to get up to speed. If you come in and you have a lot of smaller chunks, the microservice is each app has a small code base. Easy to start working on one app, on any one app. So first day on the job, if it has a microservice approach, you're going to be able to say, hey, we need this new feature in this particular part of our application. Like, we actually want to be a greedy, illegal casino, and we want to change our coin flip from being a 50-50 coin flip to a 49-51. If the coin flip server code was just a single app, and you know this is the coin flip, I'm guessing every single one of you can change this from a 50-50 coin flip to a 49-51 coin flip. Because you know that this service takes care of the coin flip, and everything that needs a coin flip is going to call this service. So it's going to be very easy for you to modify this. Well, if you had to modify it in a monolithic code base, you have to go through and figure out what function calls actually make the coin flip, what files the coin flip in, where does it actually send that coin flip, how is it stored, what data structure is it in, all of this complexity. If you just use a microservice approach, you just find this is the one application that does that, this is the change that needs to be made to this application. Serverless architecture has somewhat of the same idea. So each function is small and stateless. Without state, even easier to get started. So if you had a function that didn't have any global variables, it's going to be generally even easier to see a serverless function and say, okay, how does this one function interact with the rest of my application? So getting started writing serverless code is actually honestly the easiest one, because generally there's a single function call, and the function call is not able to have any state. So because of that, you end up with this really great universe where you have a single function, all the states read in the beginning, does the action in the middle, saves all the state at the end. The entire workflow is defined right in one function. And this reason alone, I think, is the biggest reason we're seeing that serverless architecture is growing in popularity. Because it's very, very, very easy to have a new developer help you build a serverless architecture. Yeah, Skander. No. No. Because in a serverless architecture, your function is running on a new computer every single time it runs. So you can store in global memory, but it's not going to do anything. Like, it's not going to be there the next time it's there. Yeah, Skander. Or not Skander, so Jake, sorry. Yeah, in your config file, can you have the location of your database, and then the first line of code says connect to the database? Absolutely. So you can have external state, but you can't have internal state. Yeah. All right. Can you what? Would you have like serverless lambdas calling other lambdas? Sure.
I guess like one thing that usually like I guess think about it is like I guess it seems like it's a problem because like the function you're looking at like is useful automatically.
Yeah.
Something that creates velocity.
Yes. Yeah, no, that is actually a huge problem. And in fact, that nicely transitions to the kind of second thing, is how do we test this? So testing. And I'm going to say there are sort of two different types of testing that we think about when we do testing. There's one type of testing that is called integration testing. So integration testing is how does the whole system work? How does the whole service work? So integration testing basically describes the entire experience of you logging into Netflix, selecting the movie you're going to watch, and playing the movie. So if you have a monolithic service, this is easy to test. Just run it. So in a monolithic server, you can actually get the whole experience really easy. It's really simple to test it because you've just got one service, you run it in a development environment, you run a bunch of test cases against it. Very, very easy to actually start this up. The other form of testing, which we'll go to the next line, is going to be unit testing. How does each piece work? When you have unit testing, it is easy to test each individual piece. Each piece is its own server/function. So in a microservice or a serverless environment, it's easy to unit test. It's easy to see how does this individual function work. And you write unit test cases where you say, does this coin flip return heads? Does this coin flip return tails? If we flip it a number of times, does it roughly return 50-50? We can test that unit itself. But when we actually want to do the integration, it is going to be hard. Because we have to set up all the services all at once. So imagine that you were working on just one piece of this service. Your piece works great. You can test your piece, you in your own little bubble, you can test everything about your microservice. But now suddenly you have to work with all of the other people in this class, and your thing is being used by 6 other people, which then is being used by other people. There's basically this whole graph of dependencies of the microservices. And to do that whole experience of testing from the first time the user gets on a website all the way until they're seeing a movie on Netflix, they might be interacting with all 45 of our different microservices. That's a lot of microservices set up just to do an integration test. You've got to get all of your different services running. You've got to get all of your different services communicating with each other. That's a lot of work. So it ends up being really, really hard to have an environment where you have integration testing in a microservice framework. Very easy unit tests, very hard to do integration tests. On the flip side, on a monolithic framework, it is very hard to do unit tests. Because you have to launch the entire service just to test one particular feature. So imagine that you have to boot up all of Netflix just to test on whether or not someone can put a star next to their favorite movie. If you want to just test whether or not favorites works, imagine having to boot up all of Netflix just to do that test. So that makes testing one individual feature very, very, very hard. So there's a huge trade-off between our design decisions. If we're going to often want to make sure our system works, and this is part of the reason why startups often will go to a more monolithic architecture, is because it becomes, they're focusing on the end-to-end experience. That if you work for a company that has 10 or fewer engineers, you're generally going to understand how the entire process works. You're going to understand what databases there are. You're going to understand every step of that system. But if you're in a company with 1,000 or more engineers, you're only going to have a very limited view. So you can optimize and make your microservice amazing and rely on everyone else's microservice working as well. So there's this trade-off that happens that you have to think about as a designer of a system. Do you want to build everything in one application because it's then very easy to test the whole thing? Or do you want to split it up into different microservices? And the last thing I want to talk about is deploy. So deployment is a tough challenge. So deployment in a microservice, in a monolithic approach, that's going to be expensive, so costly, but easy. So as microservices grow, you end up having to have more and more powerful individual boxes to run the entire microservice. So the deployment, the entire monolithic service. So your application needs this really beefy box because there's only one version of the application. It does not scale generally. And you're going to have a box that can handle more and more requests on your application as your product grows. But it's so easy to deploy. You just run one app. Deploying out of a microservice is cheaper and easier to scale, but hard to start up and config. So a microservice is cheaper, it's easier to scale, but you have to figure out what port on what machine is every single one of your services running. So if you have 100 different services and it's running on service 1, or something's running on port 1000, something else is running on port 2000, something else is running on port 3000. What's running on 1000? What's running on 2000? Where in the world is the coin server? How do I get access to the service that's actually going to flip the coin for me? What is the URL to that service? How do I communicate that URL to everyone who's involved with my microservice architecture? The configuration and deployment challenges are huge. And in fact, how many of you guys have heard of something called DevOps? Developer operations? Yeah, so a DevOps position, I would say like half the DevOps I know say they spend half their time just dealing with deployment of microservice architectures. How do you make sure that all of the different pieces are connected together and work? And when it breaks, how do you go in there and understand what piece of the microservice breaks? Because microservice A might break because you got bad data from microservice B, when microservice B should have never returned that data, but it's microservice A that actually crashed. Even though A may be perfectly fine, B gave it bad data, but A was the one that crashed. So somebody who does DevOps is often the person who's actually in that pipeline that says, okay, what in the world just happened? Why did A crash? Was it because A had bad code, or was it because B didn't return what it was supposed to return to A? It didn't follow the API that they agreed on beforehand. So DevOps really sits at this level of saying, how do I get a whole bunch of microservices to work together? Serverless tries to fix this. Serverless says, so in complex, due to state challenges, but easy startup. So serverless architecture, it's going to not have all the configuration problems. Because there's no state involved, it's going to be very, very simple to basically just say, hey, just run this service, run this function. It's serverless. I don't care where it runs. I don't have to have the configuration of saying this is on port 8000. This is on port 2000. I don't care about these things. I can just focus on the idea that it's going to run on some server without state, and I can guarantee what's going to happen after this function finishes. I don't care where this function runs, and because I've eliminated all the state in the function, it's easy to kind of think, it's easy to deploy, but now it's complex to design things without state. And you may be tempted to be like, oh, I'll just store all of my state in a big database and get it every single time I'm going to run this function. But if you're calling out to a database for every single random Lambda call you make, you're actually going to find that you're just going to overload your database. So there's actually a lot of design challenges, and it's actually really hard to build a good serverless architecture. I think if it was really, really easy, every single corporate company would already have it. There's definitely some advantages to serverless, but it is hard to write the code to do serverless well. Every call to the database, if you're thinking about a serverless function might run 10,000 times a second, that might be 10,000 database connections. Do you really need all that data coming from the database? Or where can you send that data? Can you send it as a parameter to the function? And there's a lot of different design challenges that happen there. So this is kind of the paradigm that you are going to get to decide as you're building applications. Do you want to build a monolithic application? Do you want to build a microservice application? Or do you want to build a serverless application? And I think these things are great to understand, but I think what is really valuable is us to see applications that make this decision. So I want to build an app with you. Let's build CoinFlip. So CoinFlip is the newest viral game that has the simplest set of rules ever. The coin flip game says that you have a number of, we'll call them Illini coins. So do Illini coins exist? I feel like this is an obvious crypto to make. So I have an Illini coin. And with this Illini coin, you can, I'm going to actually start you all out with 100 Illini coins. And I'm going to allow you to play my coin flip game. And the coin flip game has a very, very simple rule that for one Illini coin, you can flip a coin. And if it lands on heads, I will give you 2 Illini coins. If it lands on tails, I will give you nothing. Simple game, right? Everyone has 100 Illini coins. We flip a physical coin. Or for one coin, I will flip a coin for you. If it lands on heads, I'll give you 2 coins. If it lands on tails, I keep your 1 coin. So basically, you win 1 coin if it lands on heads. You lose 1 coin if it lands on tails. Expected value is 0. But you can click and flip coins a bunch. What are the technical components we need for this game? What are all the individual pieces? Yeah, Jake. Yeah, let's say they're not actually crypto, and yeah, we can just make them up. Okay, so we need a user wallet. Well, let's think so the functionality is we have a user wallet, okay, and then the user wallet might need to communicate with a database. So like a do coin flip. Okay, so we have a wallet and we have a do coin flip. We have a database that might actually store the wallet information. Okay. Is there more? I feel like we haven't quite identified everything. Anyone else wants to add a component? If not, I'll come back to you, Jake. Is this all we need? Is this a complete game yet? Oh, yeah. We need an update wallet. Yeah, so in this wallet, yeah, I do agree that in the user wallet, we probably want a get function and probably an update function. We probably want to get the wallet and update the wallet. I agree that we need both of these functions probably. Yeah. Oh, we need a front end. We actually need the game itself, right? So we actually need to present the user with some information and say, okay, here is the game itself. The game itself is probably going to interact with the do coin flip and the wallet. So wallet and the do coin flip really aren't interacting with each other. They're interacting with each other via game. And the game itself might actually have, to finish up Matt's answer, it might have a front end user interface. Yeah. Oh yeah, we might need, so do we just trust do we just let you access anyone's wallet? I don't think so. So we might need a user authentication. So the game might need to interact with the user itself. And honestly, at this point, now that we have 2 arrows that both seem to have user data, we might actually want a separate user component that handles all of the users, their bank account, and the authentication. Maybe that should be a service that communicates to other services. I'm going to go back on Jake's question and say we might need I'm going to call it like a bank or a crypto. Like there's a possibility if we don't have unlimited Linite coins, we actually have to have an API that interacts with actual backend blockchain or your actual bank account or credit card information, whatever you might have to actually get your Linite coins. And is there more? I would say that this, yeah, Jake. Oh, is this all within one Flask service? That is actually completely up to us. And that's the whole point of this, is this could be one Flask service. If this is all one Flask service, that's a monolithic application. But what if we said that this was the coin server? And that this is going to communicate via an API with the game itself. So this is one app that's going to run completely independently of other apps. And then what if the user wallet was a different app? This might be the user wallet app. And it communicates with an API. And this database, well, we don't actually build it. This is a Mongo database. And this communicates via the Mongo API. And let's say the game itself, like, I mean, we have a different app for that. This is the actual game. And the game has an API that interacts with the user or the GUI. So now we have 4 different processes running to build this game. And we haven't even talked about user authentication. So you can imagine how this is one big app, or there's now 4 different apps and processes that are running, communicating with APIs. So this is the difference between a microservice and a monolithic application. Yeah, Aaron. Yeah. Yeah. You could have a what? Yeah. Yeah, so if we think about it as a serverless architecture, does the coin flips function care about the user that's flipping the coin? No, right? Doesn't matter who's flipping the coin. The serverless function that does coin flip can run completely independently of any other information. As far as the wallet, if you have a serverless like wallet update function, it's weird to think of that as serverless. You generally, from what I've seen with design, is if you have a heavy database integration system, you generally don't use serverless for that, just because it's going to be it's expensive to start a communication with a database. So if you're going to be updating a database constantly, that's probably going to not be something you make serverless. Yeah, definitely you could do something like this. And the thing is, there's no one right answer. It is going to be fewer lines of code and way less complexity to build a monolithic application here. You can have routes for all the individual different things, all in one big Flask file. You have like 8 different Flask functions. It's easy. But if you have a microservice approach, then you can have a single developer develop on the coin server. They're doing their own little thing in their own little world. They might build the best coin server ever in the world. And you don't have to care about what they do. and you just have to worry about the API. And one of the beautiful things about microservice architectures is until the coin server is done, could you just make a function, a server, that basically just returns a coin that always flips heads? You could fake it until the application is actually done. So you can have default responses built into the microservice architecture so that you can actually work on different pieces even without a different dependency piece being done already. So this is something that is super, super valuable. So I think we should build this purple server. I think it's easy to think about how the whole thing is built as a whole. It's hard to think about how we actually build these microservices and what are involved with the API calls that go between them. How do we build up a microservice architecture? One of the biggest challenges with microservice architectures is the idea of configuration and deployment. So configuration and deployment is basically asking the question of what is the location of the dependencies? And how do I update the dependencies locations? How do I know where I find the coin server that we're going to build? How do I, if I have to take down the coin server and move it to a different port or a different computer, how do I inform somebody that that's happened? How do I manage this growing mess of microservices? Oops. So to do that, there is a really, really great, there's kind of a standard solution that exists that's already been around for 50 years. And that solution is something called environmental variables. So environmental variables are variables specific to the current runtime environment of your system. So what environmental variables are, they tell you kind of the current state of everything your system should run as, and it's easy to change and configure them as you run your application. So if you're on a device, you can always check its current state of environmental variables by running a command, depending on if you're on Windows or Linux. So I'm here on Windows PowerShell. So I'm going to do dir env : and this lists every single one of my environmental variables that currently exist about my system itself. So what this is doing is this is telling me the environmental variables of my system, of my current system, and that's going to be completely different than all of your systems. These are system deployment specific variables that are present about your system. So on Windows, I have an app data directory. So if you are building like a game or something on Windows, Windows recommends you store all of the information about your game, particular to a user, in app data. So C users WAF app data roaming is where my app data folder is. A common variable is going to be the path variable. So the path variable is a variable that exists on all systems, and this variable says, where should I look for an executable if I just run an executable? So if you run something like ls or dir or any of these programs, it's going to say, where on my computer can I find these programs? That's going to be in the path. There's something called user dir or home dir. Let's see. So on Windows home path. So home path says, where is my current user directory? Where is my home directory? So on Windows, it's on user WAF. if I go ahead and launch, let's launch Ubuntu. So if I launch Ubuntu and I type env, Ubuntu has a bunch of environmental variables as well. Notice it also has a path environmental variable. It has a home directory as well. It has some other environmental variables that say specifically present working directory, PWD, which directory am I currently on? What is the randomly generated computer name for this particular system? This is desktop-fv something, something, something. So you can see that the current user is WAF. All of these different things are user-specific information for my deployment. We can actually set things up so that we can have environmental variables that are deployed with an application itself. So when you run a Flask application, for example, Flask will check your environmental variables. And what you can do is you can define a file called .env. And in a .env file, you can define the environmental variables that you want running when you are running a Flask application. So one environmental variable that Flask understands is the environmental variable flask_run_port. That environmental variable is what port should the Flask app that's in my current directory run on when I do Flask run. So when you did MP6, I don't think we gave you a Flask port number. I think you just ran on 5000. So you just, by default, Flask chooses 5000. But we're going to have to set up different microservices, and only one thing can be on one port at a time. So by choosing Flask run port 2001, this is saying my Illini coin server is going to run on port 2001. And what I can do then is I can also then create a .env file and communicate to my, my game application that the Illini coin service is equal to HTTP://127.0.0.1 port 2001. So what I've now done is I've hard-coded the configuration of where my Illini coin service is, because I know that it's going to launch on port 2001, or sorry, 20,001. I've now hard-coded a variable in my environmental variables that say, for this particular run of this particular microservice, you can find the Illini coin service at localhost:20,001. So when my game starts up, it knows that I can go to port 2000 or 20,001 and find the Illini coin service. So this idea of how do you configure where you find the particular applications, the core way every single development environment does it, or every single deployment does it, is through environmental variables. You can see what they are in the command line, and they're always key value pairs. You always are given a key, and it has a value. Environmental variables are key value pairs. They're runtime specific on deployment. We can define them through we're going to define them through a .env file. There are solutions that do this at an enterprise level. So there's Kubernetes, for example, is a Docker container manager. And one part of Kubernetes is it sets up environmental variables inside of your container based on the deployment setup that's set up inside Kubernetes. So we're not going to get to the Kubernetes level deployment because you don't need Kubernetes until you have like thousands or tens or hundreds of nodes. But all that Kubernetes does is it automates the deployment of a bunch of containers with a bunch of specific environmental variables. We're going to be setting our environmental variables ourselves in .env files, because that way we directly see that we're changing the configuration of the runtime. We'll directly see how our code is now going to reference a line coin service. So you'll see in our code that we're going to do os.getEnv. That's going to get the environmental variable that's currently set to a line coin service. So this is going to be the standard way that we decide how we end up configuring our applications. And what's really powerful is, eventually, you may not be running this microservice on your same machine, right? As your service gets bigger and bigger, if you need to scale your service, you might have a complete separate machine that's just dedicated to running the coin. And this is what the microservice approach allows. Is we said it's cheaper because as your service gets popular, as you have more and more users, you can start taking pieces of your microservice and running on separate machines. So you don't need one really, really big machine to run your entire service. You can have lots and lots of small machines. And then if one particular microservice requires a lot more memory, you can just make that one machine a lot bigger because it's a really, really useful function. And you can optimize each individual piece of your application. So what we're going to do is we are going to start off on Thursday by actually looking at the, so what I'm going to ask you to do is actually look at the code that I'm going to send you an email with all the code to the repo of this lecture, lecture 15. Before Thursday, just take a look at all of the code and the 3 different apps. You have the base app that's actually the game itself. You have, so inside 15, you're going to see that you have a coin service that actually does the flipping of the coin. You have a Illini coin service that actually does the Illini coin and has the routes for the Illini coins. And you have the actual app itself to play the game. So you've got these 3 different microservices that communicate with each other in a Mongo database in the back end. So what I want you to do before Thursday is just download this code and run it and do a few coin flips. Just see how this code works, see how this microservice communicates with each other. We're going to make a few changes to this code and kind of see how microservice architecture works and how we can navigate, how we can change out where these services are running as we finish up talking about microservices. Then on MP8, which is coming out on Thursday, you're going to actually build your own microservice-based architecture where you're going to have to interact with a service that I've made, and your program is going to actually have to work with my program, and you will build a microservice-based application where you're interacting with other services out there to build something that my service by itself doesn't do. So you're going to extend what I've done to give additional functionality on top of my service. So you're going to be using this microservice idea of building something bigger up as part of MP8. Right now, you're going to work with an external Docker container on MP7. So if you haven't finished up MP7, it's due on Friday. So make sure to get that done. I'll be here after lecture if you have any questions. Otherwise, have an amazing couple of days, and we'll come back here on Thursday and play our Illini coin game, and we'll flip some coins to win some iCoins. See you on Thursday.